com hit.
Okay, so our next guest that's going to come up, she's going to do a short presentation on her research, and this has applications to fire rescue as well. Please join me in welcoming Dr. Amber Paul to the stage. She has an exciting new consortium that you may actually want to be part of. Dr. Paul is an assistant professor of aerospace physiology and immunology at Embry-Riddle Aeronautical University and a Wessel Fellow. A former University Space Research Association Fellow at NASA Ames Research Center, she is now a scientist with the Blue Marble Space Institute of Science. And her research examines immunity and neuroendocrine crosstalk in extreme environments, focusing on stress impacts and countermeasures. Supported by NASA's Human Research Program and the NASA Florida Space Grant Consortium, she directs the Omics Lab for Health and Human Performance at Embry-Riddle. She also serves as the chair of the Open Science for Life and Space Animal Working Group, a board-directed member of the American Society for Gravitational and Space Research, and also a co-investigator at the Center of Science, Technology, and Advanced Research in Space. So with that, I welcome Dr. Paul.
Thank you, Kendra. Hello, everyone. Thank you again for allowing me to do my short spiel to everybody. I wanted to just introduce really quickly my lab. My lab is the Omics Lab for Health and Human Performance. We're talking about having integrated understanding of biology. That's ultimately the research that I do in my lab. My background is in understanding the immune system, but I'm very much involved in trying to see how the endocrine and the nervous system interacts with the immune system, and how ultimately we can try to circumvent different ways in extreme environmental conditions. So I wanted to just showcase a few, some images of my lab, some of the research that we have been part of, some of the missions we have taken place in, as well as our annual trip to Brookhaven National Labs, which is one of the places that we can study deep space flight radiation, which is a big question that we don't know a lot about in terms of our physiology. So ultimately, a good place to study those kinds of things. So I do have a QR code there to see the lab's capabilities and any other research questions that are there, and of course my contact information there. Okay, next slide. But I really wanted to use this platform today to introduce you to the Center for Science, Technology, and Advanced Research in Space, or CSTARS. Ultimately, this is a consortium of 4 Florida universities, so the University of Florida, Embry-Riddle, FIT, and FAMU, that have gotten together to try to develop this consortium to answer the question about space manufacturing. And so what CSTARS is we are trying to transform the future of space manufacturing, and through a few different ways that we want to do that is we want to be able to get experts in the university and the government and academic institutions to try to reduce the cost and the time for making different biomanufacturing tools. We want to accelerate innovation to get those experts in one room and start having those conversations a lot more. We want to be able to develop a talented workforce. That's a huge component to develop our next generation scientists, and ultimately what these questions look like in those training types of programs that we need to implement for workforce development. And we also want to be able to reduce barriers to space access. So having integration with different launch providers is a really important goal of CSTARS as well. So who should become a member of CSTARS really comes down to everyone in this room, ultimately. Anyone that's interested in understanding space manufacturing, that comes from academia, that comes from industry, that comes from the government. Space manufacturing companies, government agencies, workforce development organizers, launch implementation providers, startup companies, ultimately getting together and trying to work through these kinds of questions. Next slide. Some of the things that we're trying to address with CSTARS include looking at biomolecules and tissue engineering and how we can take that type of information off planet. How we can study these questions in the unique microgravity environment is a very challenging question, so that's one of the main drivers for a lot of this research. We want to be able to implement advanced electronics and materials in these questions. There's a lot of expertise in biology in general, but we need to get the expertise of engineers, computer scientists, groups coming together in electrical engineering as well. We want to consider intelligent engineering and autonomy with many of these types of space manufacturing directives. And we want to also introduce recycling and sustainability for these types of questions as well. That is an important directive in order to have this sustainability in the deep space environment in particular. Next slide. And of course, I mentioned workforce development is a very big directive for C-STARS. Being able to have different programs that can help train students in particular to have that way into industry and into profession to develop those careers. Embry-Riddle, the program that I'm an assistant professor under is Aerospace Physiology. We have a graduate undergraduate program that gets a degree in aerospace physiology. We focus on these questions in aerospace, and so we want to be able to have career development for the students that are getting education in these types of fields. So workforce development is a big driver for C-STARS. Next slide. So I would like to invite you to help drive the future of space manufacturing. So I'm inviting you to the C-STARS strategic planning meeting. There is a QR code there. Again, this is going to be tomorrow and Friday, so April 24th and 25th. It's going to be located at the UF Research and Academic Center at Lake Nona. And I have my information there. I'll be around for the break if you have any questions. So thank you.